Hello students, welcome to CHN 101 General Chemistry 1. Today we are going to look at study section 4, which is state of matter and chemical reactions. The learning outcome for this study section 4 as follows. Define the term matter. Explain what change of state of matter means. Explain chemical reaction. Identify different types of chemical reactions. Write balanced chemical equation. Understand mole concepts. Calculate limiting reagent and theoretical yield. What do we understand by the term matter? Matter is typically defined as anything that has mass and occupies space. There are two types of matter. One, normal matter, and the second one is dark matter. Let's talk briefly about normal matter. This is the luminous matter that you see all around. It is composed of leptons and quarks, which can be used to build atoms and molecules, which in turn are the lattice work of everything from humans to stars. Dark matter. This is in contrast with normal matter. It is non-luminous in nature. It does not interact electromagnetically, and therefore it appears dark. The exact nature of dark matter is not well known. Now, let's talk about change of matter, change of states, rather. This change of states is always accompanied with change in temperature. Change of states is brought about by a change in temperature. A given substance such as water can exist in one or more of the three states of matter: gas, liquid, or solid. At the pressure of normal atmosphere at sea level and at temperature below 0 degrees Celsius, the stable form of water is the solid state, which is known as ice. 3 points of water. What do you understand by that? These are the three states of water, that is, ice, liquid water, and water vapor, which can coexist on a stable fashion only at a given fixed temperature and a fixed pressure called the dew point of water, which occurs at 0.0075 degrees Celsius and 4.579 millimeter of mercury pressure. Then we have three states of matter. The three states of matter are solid, liquid, gas, and plasma. As you can see, again, it depends on as the temperature changes, we observe this change of matter from solid to liquid to gas and plasma. Let's talk about little characteristics about this solid so that we will be able to differentiate them by the time we see them. A solid has a definite shape and volume. Examples of solid include ice, a bar of steel, and a dry ice. In the case of liquids, a liquid has a definite volume but takes the shape of its container and can change shape. Examples include water and oil. Then gas. This has neither a definite volume nor a definite shape. The shape and volume of the gas can change depending on the container in which they exist. Examples of gases are here, oxygen and helium. And the last change of states of matter is plasma. It also has neither a definite volume nor a definite shape. Plasma is often seen in ionized gases. Plasma is distinct from a gas because it possesses unique properties. Free electrical charges cause plasma to be electrically conductive. Plasma may be formed by heating and ionizing a gas. Stars are made up of plasma. Now, let's talk about phase change. These changes that take place in a substance may be categorized in two classes. 1. Physical change. 2. Chemical change. As you can see, a very good example is physical change of water into ice. White chemical change is depicted by seeing the conversion of hydrogen peroxide into water. The major difference between these changes is that one is reversible, while the other one is irreversible. Which one is reversible? Physical change. It does not produce a new substance. While chemical change produces a new substance, e.g., burning, rusting, photosynthesis. All these processes are examples of a chemical change. Now we go into chemical reaction. A chemical reaction is a process that occurs when two or more substances combine to produce a chemical change. As you can see on the board, you see the reactants coming together to form a product. Some terms are very important when we are dealing with chemical equation. These are, one, reactants. Normally, reactants are normally on the left-hand side, and this is the starting material for a chemical reaction to occur. If there are no reactants, there is no product. There must be presence of reactants before we can think of product. Products are substances that form as a result of chemical reaction. When chemical reactants comes together. Chemical reaction rate. This is the speed at which a chemical reaction occurs. While acceleration energy is the external energy that is needed, for a chemical reaction to occur. And when we talk about catalyst, this is a substance that alters the rate of the chemical reaction. I said alter in the sense because the general, assumption is that catalysts increase the rate of chemical reaction. But really, we have two types of catalysts. We have a positive catalyst and a negative catalyst. And a very one that is good for our living is enzymes, which is called biological catalyst. So that is why I say that catalyst is something that alters the rate of chemical reaction. So any substance that will alter the rate of chemical reaction can be referred to as a catalyst, but it does not participate in the reaction. That is, we can recover them at the end of the reaction. Why law of conservation of mass? And it's the law that states that matter is neither created nor destroyed in the course of a chemical reaction. The number of reactant atoms of a chemical reaction will be the same as the number of products. And this is what is shown on the board. And that is why, as we see later, we see how we can balance a chemical equation. Now, there are different types of chemical reactions. Direct combination of synthetic reaction, displacement reaction, chemical decomposition, double displacement reaction, acid-base reaction, oxidation reduction reaction, combustion reaction, isomerization reaction, and lastly, hydrolysis reaction. How do we identify this reaction? Direct combination. This is a reaction between two or more chemical species to form a complex product. And a very good example is the reaction between iron and sulfur to produce iron 2 sulfide. What about chemical decomposition? In a decomposition reaction, a compound is broken down. Remember, in the first one, direct combination, two things come together. But in the case of chemical reaction, there is a breaking down of a compound to produce, chemical species. So it's a sort of opposite of direct combination reaction. While in the single displacement reaction, one substitutes another. And this reaction is characterized by one element being displaced from a compound by another element. What about double displacement reaction? In this type of reaction, it involves two compounds exchanging bonds or ions in order to form different compounds. And a very good example is the reaction of silver thiazide nitrate. It breaks down into sodium thiazide nitrate as well as so we have a reaction between silver nitrate aqueous. So in double displacement reaction, it involves the reaction between silver nitrate, giving sodium nitrate aqueous and silver chloride aqueous. So you can see that in that reaction there is exchange of bonds. And the next one is acid-base reaction. The basic thing in acid-base reaction is that the product is always salt and water. And this is the reaction between an acid and a base. And a very good example is the reaction between hydrogen bromide and sodium hydroxide to give sodium bromide and water. And the next one is oxidation reduction. This is a type of reaction that involves a transfer of electrons between two species. And a very good example is the reaction between thiosulfate and iodine, to give iodide ion and thiosulfate ion. And the next one is combustion. One thing is very important in this combustion reaction: oxygen must be involved. Oxygen must be involved. And this is a kind of chemical reaction that involves addition of oxygen with another compound. And again, generally, the product is always carbon dioxide and water. And a very good example is a reaction of undecane plus oxygen to give carbon dioxide and water. And the next one is isomerization reaction. And this reaction can also be referred to as rearrangement reaction. This is a reaction that involves transformation of one molecule into another molecule, which has exactly the same atom, but the atoms have a different arrangement. And a very good example is isomerization of pentane to yield 2-methyl-butane and 2,2-dimethyl-propane. And the last one is hydrolysis reaction. In hydrolysis reaction is a reaction of water with a chemical, compound. And a very good example is the reaction of water with fat and oil to give us fatty acid and glycerol. Now, how do we balance chemical equation? Generally, chemical equation is a mathematical relationship between the quantity of reactant and that of products. And in balancing chemical equation, there are some steps to be followed. The steps are: you write your balance equation, you balance the equation, indicate the state of matter of the reactant and the product. Normally, in any chemical equation, as I've told you earlier, there are always reactant on the left-hand side and products on the right-hand side. And again, you must follow the law of conservation of mass. Again, we state that matter is neither created nor destroyed. So what you put in, you must get it out. So the only way to do that is to balance your equation. So how do we balance equation? In any chemical equation, one thing is very important. But the advice I will give is that always balance oxygen last. A very good example is tin oxide plus hydrogen. Tin will give us tin, metal, and water. When you look at this equation, try to identify the elements present. Number one, on the left-hand side, which is the product, our tin oxide is made up of tin and oxygen. We have 1 mole of tin. We have, again, 2 moles of oxygen. Then we have hydrogen as well. We have 2 number of hydrogen. While on the right-hand side, we have 1 number of tin and 1 number of water, which comprises of 2 number of hydrogen and 1 number of oxygen. When you look at it, you see that it's not balanced. How do you balance it? You take the elements one after the other. So, when we take tin first, we have tin to give tin plus water. So when you look at this, we see that, let's identify the element first. Tin is equal to 1, oxygen is equal to 2, hydrogen is equal to 2, oxygen is equal to 2. Then this is the left hand side, which are the reactants. But at the product side, tin is equal to 1, hydrogen is equal to 2, oxygen is equal to 1. How do we balance it? Let's take the other as I've said. Tin is balanced, so we don't need to worry ourselves first. Then let's take hydrogen. We have 2 hydrogen at the left hand side, and we also have 2 hydrogen at the left hand side. We don't have problem with that as well. But let's look at oxygen. At the left hand side, we have 2 plus 1, which is 3. At the right hand side, we have only 1. Now, let's do it this way. Now, let's first of all put 2 here. By the time we put 2 here, we discover that our oxygen is now 4. While our hydrogen is now 4, while our oxygen is 2. Now, we put 2 here in order to balance the hydrogen. But still, we still have 2 plus 2. We have 4 hydrogen here, and we have 4 oxygen at the left hand side, and we still have 2 at the right hand side. Still, we still need to do something about this in order to have a balanced equation. So, what do? We continue to For instance, if you want to balance this equation plus H2 to give zinc. So for instance, if you have to balance this equation on the board, tin oxide plus hydrogen to give tin plus water. So as I've told you, on the left hand side we have the reactant, while on the right hand side we have the product. As I've said, let's take it one after the other. On the left hand side we have tin to be equal to 1, and on the right hand side also we have tin to be equal to 1. So that one is balanced, is okay. Now on the left hand side we have oxygen to be 2, while on the right hand side we have oxygen to be 1. So that one needs to be balanced. So, and again, we always balance oxygen last. So let's look at hydrogen. On the left hand side, hydrogen is 2, while on the right hand side hydrogen is always 2. So we have issue with only oxygen. So and how do we go about it? It's very simple. Since oxygen is 2 here, what we need to do is just to add 2 to this place. And by the time we add 2 to this place, oxygen is now balanced. But again, another thing has come up. And what is that thing? Hydrogen has now turned to 4. So in order to do it, we just go back to our reactant, then we add 2 to this place. So making it to balance. So when you look at this now, you see that this one is a balanced equation, because what we have at the reactant side is equal with what we have at the product side. When we talk about mole relation in balance equation, how do we do it? These are the chemistry problems showing how to calculate number of moles or reactants or products in a balanced chemical equation. Number 1, mole relations in balanced equations. These are worked chemistry problems showing how to calculate the number of moles of reactants or products in a balanced chemical equation. For example, question number 1. So what the question says is that we should determine the number of moles of nitrous oxide needed to react completely with 3.62 mole of. So as I was saying, the first question, we have to calculate the number of moles of nitrous acid, that will be needed to react completely with 3.62 moles of N2H4 for the reaction, and this is the reaction that is shown on the board. So what we need to do is, first of all, we find the relation between number of moles of N2H4 and N2O4 by using the coefficient of the balanced equation. So from the reaction, we will see that first of all we make sure that our equation is balanced. So then after the equation is balanced, then we can go ahead. So from the balanced equation, we can see that 2 moles of N2H4 is proportional to 1 mole of N2O4. Therefore, the conversion factor is 1 mole of N2O4 all over 2, which represents the number of moles of N2H4. So moles of N2O4 will be 3.62 moles, of N2H4 plus 1 mole of N2O4 all over 2, and moles of N2O4 will be equal to 1.81 mole. Now, let's go to the limiting reactant and theoretical yield. So how do we identify the limiting reactant and theoretical yield in an equation? Normally, the limiting reactant of the reaction is the reactant that will run out first if all the reactants were to be reacted together. And once the limiting reactant is completely consumed, the reaction will cease to progress. The theoretical yield of the reaction is the amount of product produced when the limiting reactant runs out. And a typical example is, let's consider this reaction: 2H2 plus O2 plus 2H2O. If 20 grams of H2 gas is reacted with 96 grams of O2 gas, which reactant is limiting reactant? So in order to determine that, again, first of all, we have to write a balanced equation. We first of all see that the equation of the reaction is balanced. So to determine which the limiting reactant is, first determine how much product will be formed by each reactant if all the reactant was consumed. The reactant that forms the least amount of product will be limiting reactant. To calculate the yield of each reactant, the mole ratio between each reactant and the product is needed to complete the equation. So the mole ratio between O2 and H2O is 1 mole of O2 all over 2 mole of H2O. The molar mass of each of the reactant will be given and as stated on the board. So, and again, all the units is gram per mole. So now, how much H2O is formed from 20 grams of H2? In order to get that, 20 grams of hydrogen times 1 mole of H2 all over 2 grams of H2 times 1 mole of H2 all over 1 mole of H2, and we also plus 18 grams H2 all over 1 mole of H2O. And now, how much water is formed from 96 grams of O2? Gram of water that will be formed will be 20 grams of H2 times 1 mole of O2 all over 32 grams of O2 times 2 mole of H2O all over 1 mole of O2 and 18 grams water all over 1 mole of water. So gram of water will be 96. When we do the calculation, it gets to be equal to 108 grams. So much water is formed from 20 grams of H2 than 96 grams of water. Therefore, oxygen is the limiting reactant. So thank you for listening.